Welcome, I'm Bill Wake. We're here working on a program to compare tunes for similarity, sort of for musicologists who are investigating multiple versions of the same tune, basically. And we're to the point where we want to handle chord names. We don't really do anything with them, but we need to parse them, and I think we'll put events in the stream for them that other things will ignore because they don't need them. All right. Now, like everything in ABC notation, it gets complicated. So the basic thing they do is they put a chord name in quotes, double quotes. Okay, so here's quote AM7 A2D2. And you can write the chord in a lot of ways. So you have a note A through G. You can have sharp, flat, and then you can say major, M or minor, maj for major, dim, diminished, augmented, sustain, 7, 9. I guess that should include kind of any number, although I've never seen, I guess I've seen 13ths, but that's it. And usually never a 1. 2, 4 you see, 3 I've never seen, 5 I've seen occasionally. So I don't know, they're all there. All right. Alternate chords indicated for printing purposes. Oh, can be enclosed inside parentheses. All right. And then we should be able to handle Unicode versions of flat, sharp, and natural. Okay. And then I noticed down here, oh, wait, there's some more. And they put other stuff in parentheses. So we're just going to deal with chords. Now, somewhere they say annotations and decorations. The note, this is not really accurate because they put it after. Oh, they put them both before. Okay. All right. So we're just going to handle chords. I don't know, annotations. The string within double quotes is preceded by one of the symbols. Well, that kind of makes me think I could just gather text strings and not interpret them. That would be okay. So we'd cover chords, maybe if it matches this structure. Well, okay. I guess we'll start here, and then we'll maybe add this. For a note is this order. I don't know if that's really quite right. Okay. Okay, musical names, chord names. And let me turn this on. Okay. So where we were yesterday is probably the right place. It's note line parser. Here. There's a grace note parser. There's annotations. This and not that and match that. Okay. Now, what do we do with annotations? Because notice chords would be covered by that. Where is this used here? Annotations. Decorations. See, this kind of should match the description here. Grace notes, chord symbols, annotations, decorations, accidentals, notes, octave. So annotation, decoration, I guess we left out grace notes. I thought we had them somewhere. Maybe we ignore them. I'm not sure. I guess we're putting them in as notes. It's really a grace note. And Grace note parser. Where's this called? Well, surely he's used. Oh, right here. It's a little different than you'd expect. Okay. Let's. So annotations are optional. I think that's kind of boring because we've just said they're repeated 0 or more times. With spaces between them. Okay. I think we're going to have to say a chord is a different thing. That's going to be a little tricky. What's this order again? Grace notes, chords, and annotations. They sort of come in order. Okay. Let's get some tests going. Note line parser. Okay. And we're going to need, we're going to put in a chord and make sure the event shows up. Okay, so bar lines. Is this any better view? Which one? This one? I don't know where that's coming from. Notes captured between bar lines. Fix that little typo. Captured between bar lines may have spaces. Okay. All right. I think bar lines, let's add this at the bottom. Okay, and I'll leave the throws in. I don't have to worry about it. Okay, so check notes seems like it's kind of doing things, or we could be looking for events. I think we're looking for events. Okay, so let's just take this as a model. Okay, so try events. Let's get a G chord with a D in it. Okay, and that. Okay, so it's bar line, quote G, quote D. Okay, so this is simple chord. Don't need that. All right, the expected events, we want bar line. We want a chord. I don't know if we need a, well, okay, we got another bar line at the end. That's fine. We don't have chords yet. Event.chord. And then I think we're just going to give it some text, G. Okay, and a comma. Okay, so this is looking for simple chords. Event type has no member chord. Let's go find event type. All right, he's got notes, rests. Let's give it a chord. And we're not interpreting them really, we're just passing them through. I'll probably transform them a little. Okay, and somebody's going to complain about this for sure. Switch must be exhaustive. Okay, so debug description for a chord. Let's put that here. Case chord. Let name. We'll print it. I don't mind not testing a debug description into place. Okay, I don't need that there. All right, so I think that should be good. Should fail properly. Oh, missed one. Event 2 parts. Okay, make parts. Well, we're ignoring chords. Okay, so let's just put them in bar line, rest, note and rest. I guess chord is similar. Case chord. We're gonna just do a break. Come on, editor, you're supposed to take care of that for me. Okay. Back to our test. Okay, should not match. We got the bar line. I don't know where that bracket's coming from, but comma D4. See, okay, well, we have no chord there. Okay. Excuse me. Okay, so we have no chord event coming in here, which makes sense because we don't put one in anywhere. All right, now where's that annotations? Well, let's let chord name equal. We know we have to get a this and let's see. So it's well, note. Let's start with just the single note. One of range. A to G. Now they don't use, let's see, what do they say? Note can be A to G. They don't mention lowercase. The bass can be any letter with or without a trailing. Case does not affect the pitch. Okay, well, this is going to be a complicated parse. All right, so we don't need to know the quote was there. We want that, and then a following quote. Okay, so chord name. I hate to be. I mean, I can have chord names and annotations. This kind of implies they should come first. Annotations or decorations. I mean, they haven't defined what this slash means. Does that mean you can't have both? I kind of doubt it. Open and close chord delimiters. Okay, so that's different than the chord names, except for chord symbols. There's the chord symbols. There's some notes. There's some chord symbols. There's who knows what that is. Dot equals that. V equals G. Two squiggles C. Like, I don't know. What do they mean? Each tie should come in and be followed by a space. Okay, we said that already. Should enclose note sequences. For example, V dot equals that V may be a downstroke or an upstroke. I always forget which is which. Okay. Now, what I'm wondering is, like, do they really care if chord and annotations come in any order? I'm going to say we could accept them both. There's so many places they allow and encourage you to be accepting of anything. Okay. But, all right. So, chord name. The problem is if I put it in here, does this... That ignores it. Rest or note parser. Okay, this thing gets ignored when it gets matched. That's not really right. Boy. I mean, I guess we could ignore it and not put in the event. But if you see here, because everything points to this, and then once it's done, it points back to it, everything else is ignored. And maybe we should just ignore the chord symbols too. Match them and ignore them. I have a tension, and it's like, do I really want stuff coming through? Because the parsing is so much work. In some ways, I want to parse it completely, produce events that are sort of halfway but semantic, and then analyze those and produce my musical structure inside. And here, I'm kind of gonna add this in. I can have a chord name. And have it ignored. So I'm going to change my test. I'm going to say chords should not show up. Okay, so let me revert this. No, revert this. I don't think we need a chord representation. We're just going to say it's not going to show up. All right, so let's take that back out. Where's the event? Okay, I'm going to revert this one. And then this one, I think my change was a chord, right? Yeah, let's revert this one. Okay. Now this one I want to keep, and the test. All right. So let's chords detected and ignored. Okay. And then, I don't know, where's this events? Events throws if there's an error. Okay, so we'll get a warning. We should get that warning right now without this thing used. Let's make sure that's the case. Oh no, it won't, because annotations are very broad. Well, maybe, I don't know, if I'm willing to ignore it, I'm ignoring annotations and these. Let's take this out too. Let's make this annotation or chord name. Okay. And take this out. Take this prefix off. Okay. And I'm going to make this chord names. And then there's no reason to keep it simple. G flat 7th with an F bass. Yeah, make it a C bass. Okay, so that's a fancy chord, and it's just ignored. And this should already pass. Okay, chords are easier than I thought. All right, make sure chord names are ignored. Did you really run? Oh, big. 1DC that is not equal to, well, spell it right. Okay. Don't appreciate Xcode not running that test for me. All right, just make sure everything's clean. Good. Okay, chord names. Chord names. Good. Alrighty. And now rhythm. I don't know if we can find one of these. These represent sort of a different way to write dotted notes. The classic one is a Scottish dance called a strathspey. Here it is. Yeah. Bump ba-dum 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 ba-bum ba-dum dum dum da 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 da. So you see this dotted note. So it's a dotted eighth to a 16th. Okay, so dun 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 dun. And in here they're indicating that with the greater than sign. So that's we're gonna have to. That's gonna be some work. But it's saying A followed by that, then the next note should be half its length. Okay, so the A gets the dot. It's like putting a dot on that one. All right. And let's see if we can find an example. Now the session is Irish music, so let's find a search. Okay, so let's look for a strathspey. And let's take Winifred's. Let's see if their ABC uses this. No, see, they're using a different way, which is the threes. Oh, there's one. Okay. Let's Let's download this, make sure everything's blowing up as it should, I guess. Okay, and we have Winifred's dress. Let's put that, well, I'll put it on my desktop. Even though I hide that mess from you. And we'll run. Open a file. It was Winifred's, so it'll be down here a ways. Okay, it parsed with no errors, but I think the reason it has no errors, let's go back to note line parser. I'm pretty sure he's ignoring less thans and greater thans. There it is. Yeah. So that thing gets ignored. Do they apply to notes as rests as well as notes? Previous note is dotted. Oh, and you can have multiples. Oh my goodness. Well, what this means is we got to carry some state between these two notes. And I think the way we're doing it, we parse the ABC into a series of events, and then we run through the events and generate this musical structure. So I think if we treat the greater than as belonging to the first note, and then make it also be an event, modify the first note, and then be an event ready for the second note. Less than, oh, okay, greater than is dotted, then the note, less than is the left note gets the short value. The following note is dotted. Okay, so I think it's got to be part, well, it's got to be part of rest or note, parser. Excuse me. Rest or note parser equals rest parser or note parser. Okay, and note parser is passed in. We have a note parser. Note parser. Oh my goodness, how are we going to do this? I think we're going to use our old friend Peak. Okay, so, gosh, it's all just so hard. Okay, so you can have a flat, you can have a sharp, which are the two accidentals, or you can have an equal, which is a natural. Then you have a letter, upper or lower case, octave modifiers, and an optional tie. Now, duration, let's see what that thing is. Duration parser comes in. Let's get that one going. Okay, so you can have digits or a slash and digits. So I don't have any mechanism that lets the event modify a previous event. And I'm not sure how to make this happen. I mean, the easiest thing would be to just shove those less thans or greater thans in between the two notes and let whoever comes next sort it out. But the problem I kind of have, well, let's see. See, I'd like to consume them, the characters, if I could. I think if I consume them, I won't have the chance to put them as a separate event. Now, it seems wrong. I mean, actually, there's no way to make it work with the parser we have because it's able to backtrack, and so you can't set up like semantic states and carry them forward. You really are treated as a functional kind of thing, like pure inputs to pure outputs. And, the structures like rhythm and note and all that stuff, they're treated as the output of whatever the current, the current state of the parser is, but you don't know what backtracking got you there. So you can't do state that accumulates. You have to kind of make it all part of the state. It can't, in lots of parsers, either like manual or Yak or Bison or whatever, there's usually some little way to sneak state between statement types. Excuse me. Those tend not to do backtracking, so it's not so much of an issue. If you're backtracking, you got to make sure you peel back any state that you set up. So, hey, Warner Archives, welcome back. So I don't know the right way to go with this. I think something about note parser. It would be convenient if a note could use these greater thans and stuff as durations. But I'd have to track that duration through as part of the resulting state. Not the worst possible thing. But it's adding stuff to the note, I guess. Because the note parser produces a note. I mean, that seems perfectly reasonable for it. The kind of note it would produce would be something that says, hey, I'm matching, my duration is, 1.5 because I'm using a greater than or less than. And I want you to take note of that. So when you get to the note after me, you make it short. And we have to somehow indicate that. We can't do it with a duration because you can specify this duration without using a greater than. And if you do, then you have to specify the dotted part too. I don't know if that shows up in this example. Let's find some. So, okay, third note is dotted quarter to an eighth. Let's see how they represent that. Third note, G, B. Well, how is that going? G is dotted to a B next. G, 3, B. Okay, so the B is an eighth note already because of this. And then G3 says make this one 3/8 notes, which is really a quarter plus an eighth, which is a dotted quarter. And this one is by default an eighth note, so it's already thin enough to be a simple note. But then down here, I guess in the second measure towards the end, you got a A to B. Second measure here, A to B. This one, dotted eighth to a 16th, they use that notation. Okay. What about this one? An E to a G, dotted quarter to a G. Yeah, probably E to a G. Yeah, there's another E3G. So, yeah, what does that do? Well, what are my choices here? I'm getting balled up as usual. All right, so the one choice is I somehow parse this thing with a little bit of look ahead, and it knows like, it's fine, you know. That's the duration. It leaves it with a regular duration in there. The peak stuff is sitting there, less than, say. We can create an event for that. And then the dotted note that follows is going to be left as a regular note, and that's how it goes in the event stream. So original rhythm note, duration markers or dotted markers, and then an original duration note. And the interpretation in converting events to music is it's got to figure out that it sees the duration thing and then adjusts the previous note and the following note. Okay, so I guess that's one thing is kind of peak for it here. Another way would be don't even peak, just treat it as an independent thing, and use it to, in a way, that's probably the best for now. We would just put an event out that says I'm a less than marker, and then somebody's got to go back and say, hey, look, we got one of those. You know, make sure when you convert events to music, you adjust things. All right, I'm going to take that approach. Have I put a test in? I don't think I have. Note parser. Well, here's note line parser. I think we want note parser tests. Note parser tests. Okay. Is that... Well, I'm saying it's not part of the note per se. And I think the standard kind of agrees with that. Where's that bit about the order of things? No, it's fine. Chord name, chord symbols. Okay, note, active note length. Okay. I don't know what this dot equals. Let me take a diversion and find that thing. The arrow is a strum pattern. Dot. Oh. Equals G is G natural. What dot is? Dot equals dot equals dot equals. Equals G naught. Annotations and decorations. Maybe it's one of those. Annotations. No. Decorations. Decorations. Oh, dot is staccato. Okay. So that's just saying strum down, down bow. I guess strum out on a guitar maybe, and do a staccato. Okay, so that's a modifier to the note. Looks like it means more than it does. Okay, so stroke out, it's staccato, and it's a G natural, lower octave, and 2 beats. Okay, and where'd that less than thing go? Okay, broken rhythm. All right, fine. Okay. Well, we can use that word in ours too. So I'm going to say whenever you see a note, just sort of appear of the note, you can have this symbol. All right, that gets us back to note line parser. Rest or note. Okay, so this, I think this whole thing can separate. All notes parser. Keychain, okay. Notes parser. All right. Yeah, so it's all notes, it's an inline field, it's a bar line. I think this is a brand new thing. Instructions, that's inline field. Okay, let's make this a broken rhythm marker. Oh, well, let's get a test. We're going to do something to the events. Okay, so we're going to have, let's have D greater than C. Well, let's make it a little interesting. All right, so I expect event, I expect a broken rhythm greater, doesn't exist yet, and I expect another note. Okay. Now the contrast with last time is that event really does need to know this. Rhythm, well, it's closer to these than those. Broken rhythm string. Okay, now down here. Switch. Okay. Pressure test. So this thing should be okay now. All right, let's see if this test fails. It would be hard pressed not to. Oh, we missed one. Okay. Well, this one we're not doing anything about yet. So we'll skip it. Okay. Good. All right, we got D, C, but not D broken rhythm. No, that's not right. Expected should be D, C. Always worth checking those expectations. All right. Now, D, C is not equal to D broken rhythm C. Good. Okay, so note line parser. We said this is really a new kind of parser. Let broken rhythm parser equal, well, it's really plus match less than or plus match greater than. So it's either one or more less thans or one or more greater thans. Okay. And if you get this thing, you should return well, we want an event. I guess everybody's putting out arrays of events. Okay, so we'll do event. $0. Oh. String. Okay. Now, event to closure type. Yeah, I made an array. Because everybody's putting out arrays and then they get flat mapped. Because some people put out more than one event. I think that's an old message. All right, this should still fail. I haven't hooked it in. It should build though. Cannot convert event value event. Array of literal element. All right, what's the matter? Unit length instruction produces an array with one event in it. We produce an array with, oh, I need to capture everything. Well, I may as well do this then. Parenthesize this. I don't know. Might be easier to read if I do this. So he was only applying to the last thing and left the other one hanging. Okay, so I have an event. Now, if you're an all notes parser or an inline field, well, let's add that here. You could be a broken rhythm parser or that, and you'll get flat mapped. Okay, so let's run the tests. Oops. DC is not equal to broken rhythm. No syntax error. Oh, I still got the old ignoring thing. All right, so we capture broken rhythm events. Okay. Now, I'm going to look at event to parts. I'm not happy with this thing already. It's already pretty big. Okay, so I think I've got events and I get a note. I don't have a way to look ahead, and that's a problem. Now, if I saw a broken rhythm, okay. If I saw a broken rhythm, that means the previous thing should be a note, and I should adjust. Okay, so what I'm going to do, when you wish you had access to the previous thing or the following thing, is you can zip this with itself. So let's find zip. Is that going to be right? Well, zip doesn't let you deal with the last thing. Ugh. Okay. And I don't know what is events? It's an array. So I do have the option. All right, let's find an example. Swift zip an array with itself. Well, this is probably the best example. All right, so zip takes two sequences, which an array is one, and it produces a zip2, which is kind of a tuple. Okay, returns a sequence of tuples. Okay. And yeah, you can get the two values out. So it takes 1, 2, 3, 4, and 1, 2, 3, 4 in letters, and turns that into an array or a sequence of 1 with 1, 2 with 2, 3 with 3, 4 with 4. Okay, and prints them. All right. And zip returns a new sequence. Okay. Let event pairs equal zip of events with events dot rest dot skip dot, wish I could remember, events dot drop first. Okay. So that takes the event, and then the event, this starting at the second item, and then deals with them. Okay. now the issue I'm having is A, B, C will yield us A, B, B, C. Okay, and that means we haven't processed the last event. Okay, so that tells me I'm going to have to take events.last and handle it separately. Okay. Let's extract this. I don't know what all it's going to need for state and stuff, but we'll extract the method, the contents of the switch into a method. All right, and this is handle one event. Handle event. Okay. And handle event is really just the switch statement. Every state it uses is part of the global, well, the file, this object's variables up here, those fields. Okay, so handle event, and then that should, and then I think I have to do handle event, events.last. Okay. Okay, I guess if events.last not equal nil, then handle it. All right, that should be equivalent. We're not using event pairs yet. This is just me. Okay, and then we don't need this yet. Okay, so that should just be basically an extract method, refactoring it and creating an object nobody uses. Should be one failure, same as always, or previously. This should, oh no, it's pure refactoring still. Okay. And then, oh, event parts. All right, and now I'm going to use these pairs. And pairs for each event and ignored. We're just going to use the first one. And then I think if I leave this off, it should blow up. Something should fail because it didn't get, the last event didn't get processed. Yeah, good, good, good. Okay. And if I put it in, it should be okay. Okay, good. All right. Let event to part use pairs of events. Okay, so I'm mostly, well, I'm going to keep pushing. Okay. Event and next event. Let's make that available to handle event. Event dot. Let's say rest. We'll just stick an arbitrary note, arbitrary event there. Rest. Now handle event needs to accept this second event. Again, we're still not using it. I think I can just do this of event because it's not used. Okay. Access to the following event. All right. So I think that gives us some setup. You might call it prefactoring or refactoring in advance, but we're extending the design to support something we want soon, but in a way that doesn't break anything in the old world, and goes from there. Okay, so now event to parts. Right now, broken rhythm is empty, and I think what we want to say is if you're a note, right, I think if you're a note followed by a broken rhythm, you're going to do something special. Okay. But I think we need to take a break first because that's going to be a little more tied up. All right, so see you in 3 or 4 minutes. Okay, welcome back. Alrighty. So I think we're to the point where we got to say there's, we need a test to take us further. So let's get rid of some of these. And let's find the event to parts tests. Okay, knows its measure. Okay. Check repeats. We don't really need repeats. Okay. Well, what we want to do, we're going to take a stream of events. Oops. Let's put this on a test. Test broken rhythm. Long, short. Okay. So events, we can be... All right. I don't need endings. I just need a broken note in the 2 places. A broken rhythm, sorry. Let's see, so broken rhythm. And we're going to have to make those quarter notes, I think, to... Well, we can do whatever. Okay, let's make this one. All right, and if we go back to our guide, this is a double dotted note where the first one's longer. Okay, so it'll get 2 dots. So if 8th notes get beats, this is 1.5 8th notes and half an 8th note or 16th note. If it was double dotted, it's a 32nd note, and then this gets the rest. I gotta say it that way. All right. I think our note, we can specify the rhythm somewhere after the key. Okay, so we're doing a quarter note A and a quarter note B. So if we didn't have broken rhythm in here, let's define what this should be. Check repeats. I don't care about that. Notes for yeah, let's do that. Notes for parts. We're going to have to get some parts somewhere. Events. Okay. Okay. But actual equal notes for parts defaulted to the A part. Okay. And assert equal. Well, let's see what notes for gives us. Is it a big rave string? Yes. Okay. Actual. And then what are we expecting? Well, I'm expecting, and I always forget how we write these, but A 1 4 in the key of C or something like that. This is the lazy way to get your assertions. Okay, I'm not using anything new, and I'm just going to make sure we get what we get. But it should be a quarter note A in the key of C and a quarter note B in the key of C. All right. A 4. Oh, rhythm didn't come through. I guess we're defaulting to quarter notes. Okay, we'll try again. A4 1/8 C is not equal to, okay, I guess default is eighth notes. I can work with that. Okay, that gives us a starting point. All right, now if it were one of these things, then this would be a dotted eighth note, which is 3/16, and this would be 1/16. Okay, but it's 2, so it's going to be, sorry, 3/16 and 1/16 is a quarter note, just like 1/8 plus 1/8 is a quarter note. If you did double dots, it goes to 30 seconds, and so we got to have 8 30 seconds total. So this will be 7 30 seconds. This will be 1 30-second. And this, so 7 30-seconds plus 1 30-second is 8 30-seconds, which is 1 4. So should be that, I think. It's tricky to get these multiplications right. But let's see. All right, now this should fail. Okay. And it should say they're just eighth notes. Okay. Now we get the fun. All right. So the deal is the switch statement can do this stuff. And I'm not quite sure how it's... I think we switch on both of them. Maybe it's a pair. Note, and I forget how you say anything. Let's do a quick search on Swift. Swift switch with a tuple. No. Yeah, this is... So you put in a pair and then you make the pair. Oh, and you can restrict it. Now, I don't know where you can... I don't know if you can say B not equal. There's like an else you can get out of this somehow. Yeah, I mean, it's close. You can ignore it. Okay. Okay, gosh, this is a hard one. All right, let's ignore it for now. Let's get everybody ignoring it. This guy might not need to. We might decide rests get the same treatment. I don't think we've specified it. And we got to make sure we're exhaustive. So that's what we're up to. Now notice only this has cared about this so far. So I don't know. Okay. This should all fail the same way. One failure because we don't handle this case. The note that. Okay, so I want to let next think I can do it like that. Okay, so I guess we want to say let's say var adjustment is rhythm 1 1. So we're going to multiply by 1 1 by default. If let next event, well, if let dot broken rhythm of rhythm spec rhythm. So if that new event is a broken rhythm, we got to make an adjustment. Okay, so if it's a broken rhythm, capture rhythm and decide. All right. If rhythm starts with, well, if first equals greater than, we're going to do something. Okay. And we're putting in a conditional requires initializer. Variable binding in a condition requires initializer. I don't know what that means. Variable binding in a condition requires an initializer. I thought I could say it there. Rhythm. Okay. If the rhythm is equal, okay, adjustment equals well, we want to take the length of that thing. Well, somehow there should be a power of 2 for every greater than. It's let's figure that out first. Let count equal rhythm dot count. Okay, I think that's useful regardless of what we do. Okay, now if that was 1, I would multiply the first by 3 halves and the second by 1 half. But 3 halves. This should be equal next event. Something like that. All right, we know we're not going to produce empty broken things, so I'm going to say there's going to be a first character. All right, if it's that, let adjustment equal rhythm. Is it 3 times that? Well, if it's 1, it's 3 halves. And if it's 2, it's 3 quarters. And if it's 3, it's 3/16. Is that true? And 1/16 for a quarter note. I think so. Okay. So let's is it exponent? Do I have to do it myself? Pow AB. Dolly, yeah. Right. Yuck. Yeah. Maybe I'll do it myself. Yeah, I don't want to be that clever. Yeah, that's what I'm going to do. Reduce 1 star. Okay. Let denominator equals dot let's see, equals rhythm dot well, let's do reduce 1 twice the value. I think that's what I'm going to get. Okay. This gets ignored. Okay. Oof. He's still not happy. Okay, and this is denominator. It's already a var. Okay. All right. I got some approximation of calculating the rhythm. I'm going to multiply it. Adjustment. Two failures, not just one. Okay. 3/30 seconds is not equal to 7/30 seconds. My numerator is not right. Let's do 1. Now, yeah, let's start with something simpler. See if I can get that at least right. Okay, so this should be now 3 30-seconds, 3/16 and 1/16. That's stop. I hope you're done. Three sixteenths, 1/16, still totals a quarter note. We're only doing 1. Let's see if I got this formula right for at least one thing. Ooh. Unprintable ASCII. Where is it? All right, let's go back. What's the other failure? Broken rhythms are allowed. Okay. That sort of makes sense. Why are you... Okay, I think this test is probably wrong. Check tune parsing says CD. Well, that's not going to be right, because if we do this right, these things are going to have other stuff going on. Okay. Now, this, okay, if we don't need it, we don't need it. This 3 is probably moving keywords out. Okay, yeah. Why is he not exhaustive? Note. Case is already handled. Yeah, I know. Okay. Let's try again. Oh, I messed something up. I think I deleted too much there. Okay, that one we can save. That to parts test. How are you doing? Okay. Is 3/16. Oh. He was still wrong, mind you. Okay. 3/16, 1/8. That's what I expect. No, it's not what I expected. Okay, that's progress. All right. We are only dealing with the first note. We're not dealing with the following note yet. Okay. Now, I don't know why. Normally an eighth note. Let's see if I get this right. Normally an eighth note is 4/32, right? Just kind of math still. Doesn't always work in music, but an eighth note is 4/32 note. So I think if we have one of those, it should be 3/16. It's still it still adds up to a quarter. But the first one is 1.5 times, and the second is half times. So half of an eighth is a 16th. 1.5 of an eighth is 3/16. Music did not adopt the metric system. Okay, so I think the fact that the first one's right is we haven't dealt with the state that has to continue. And if a note, oh yeah, this is getting ugly, isn't it? Well, what it means is we have to keep some state moving forward to say we just adjusted a note and now the following note needs an adjustment. All right, so again, we'll get this right for this one. Let's get both right, and then we'll work on multiple greater thans. Okay, so the test says 3/16 is calculated correctly, but this is still an eighth note. It didn't get the dotted. Okay, so what I'm going to say is if there was a broken rhythm thing, then we're going to have to set handling broken rhythm to true. And that means we need a variable for it. More state being carried along. All right, that's endings. This var handling broken rhythm equals false for starters. Okay. So if the next event is that, if the next event, well, I guess if the last event was left handling broken rhythm true, then we need to deal with that. So I'm saying this is getting complicated. Okay, so adjustment is rhythm 1-1. So that's sort of a starting point. If we are in fact handling broken rhythm, well, one thing is we're going to not handle it anymore, is false, but we're going to make adjustment equals adjustment equals, well, it's not enough to be a Boolean, is it? We need the count, or maybe the rhythm. Let's make it equal rhythm, which should be a string. Okay. I'll make this a string. And we'll start out empty. Okay. If handling broken rhythm count is greater than 0, if it's got anything in it, I guess we could say is empty. If this thing is not empty, well, it's going to be coming in at the end. We're going to make an adjustment. Well, maybe that's the denominator we should save. Okay. Broken rhythm denominator. Okay. Okay, if there is one bigger than 1, then we're going to make an adjustment to our rhythm. Okay, and that's going to be rhythm of 1 over the denominator. Broken rhythm denominator. Okay. I think that'll do it. Okay. Oh, this one passes. Okay. Let's see these failures. They're going to be note parser tests. 3 failures. Yeah, these are not correct because they are checking the notes but not the rhythms. So let's go to check tune parsing. It's just expected note names. It doesn't have rhythms. Check tune parsing. Oh, that's this one. Right. Name in key 4. Well, I don't know what make note defaults to. That would be worth knowing. It doesn't give it a rhythm. Well, what does rhythm default to? One whole note. My inclination is to say these tests are not accurate. They're implying that the lengths of the notes are equal, and they're not. But I think we're going to cover these cases. So I'm going to move this. Well, no, I need to make sure I cover. I think if we handle this case, it covers that. If we handle this with more than one, it covers that. So I'm going to take these tests out. They're no longer legit. They really were when our original way was just to ignore less thans and greater thans and just throw them all away. And now we're processing them. So let me make sure that's the only problem. Okay, so we handle single greater for dotted notes. Okay, now, cool. What is going wrong? All right, I think I want to handle the other way next. So we'll take this out. Let's do the short long case. Okay, now this one, we got a less than. And so it should go the other way around, 1/16 and 3/16. Okay. And well, okay, let's see it fail. We don't handle less than, so it's going to fail. Okay. They are both eighth notes. Oh, interesting. Oh, okay. It used that denominator. Oh, yeah. Okay. Well, it's wrong on 2 counts, I guess, but that's okay. We need a failing test. All right. So what's happened is we checked if it's greater than. Let's check if it's less than. And less than, we're going to do something else. Okay, what are we going to do? Maybe we should be calculating the adjustments. I don't know. All right, so if we have one less than, then we want to be half. Okay, so the denominator is 2 is all right. So I think we just have to do adjustment equals a rhythm of 1 over broken rhythm denominator. Okay, the challenge is the next time we come in with this broken rhythm thing, we need to know what it really is, what it should be for us. Okay, and I think, I'm working my way around, but okay, this should get the first note right and the second note messed up. I think it'll be 1/16. Okay, yes, both are 1/16. Okay, right. So I think what has to happen, where adjustment is calculating the adjustment for the current note. I think we should make an adjustment for the next note as well. Okay, so I'm going to change this again. Next note adjustment equals rhythm 1 1. If you multiply by 1 1, nothing changes. So let's take that into account. Okay, so where do we reset this here? Let's turn that into next adjustment. Okay. And I think in this case, adjustment should equal next note adjustment. Okay. If well, we don't really need to care. I guess we're making this redundant. Let's do that. Oh, we still need to know if it's an adjustment, though. Do we? Well, let's do it this way. I think we can get it and then simplify it. Next note adjustment equals, not equals, rhythm 1 1. Okay. If it's not that rhythm, then we need to adjust. So we adjust it and reset it so next time it is. Okay, now this denominator, let's make it a var. No, I guess it can be a let. Okay. And here's the swapperoo, I guess. Okay, if this, all right, if this is a greater, then the current adjustment is that, and the next adjustment is 1. And this one is the opposite. Next note adjustment equals rhythm 3, which is not really quite right, but it works for these two cases. Okay. I think I'm approximating it. Now, do I multiply by that somewhere? Times adjustment. Okay, yes. Good. Let's see. I believe it should pass. Okay, so we handle broken rhythms with 1 less than, i.e. short than long. Okay. Now it's the computation that's not right, but let's straighten out this next note adjustment stuff. So I think next note adjustment, well, if it's 1 1, this adjustment is that. I think we should be able to use next note. No. Maybe that needs to change after it. Ugh. Okay, right at starting point, next note adjustment is 1-1. Okay. I think we can use next note adjustment. I think this is going to be okay. That, and then that already happened, so that's no longer needed. So now we're saying adjustment is the previously settled adjustment, which could be 1-1. And if it's not 1-1, then we reset it. Okay. And okay, so we're using adjustment, and we're using adjustment down here. If it's not, then we're going to set it back to 1-1 for next time. Okay. Now, if we are followed by a broken rhythm, then we're going to calculate the denominator and adjust. Well, I think he should be next noted. I think he should be adjustment times that. And same thing here. Okay, let's make sure this is going in a good way. Okay, so now where it's getting tricky is next note adjustment can get touched in both places, can get set in both sides. Okay, but I think I'll take this for what it is. Simplify next note adjustment. Okay, now, I mean, my goodness, but yes. So we set the current notes adjustment based on the previous sequence of events and based on the current set of events, which seems right, or at least right-ish. Okay, now I got to get these threes adjusted. I think I can go back to denominator. This is no longer a field. It's just kind of a local thing. Okay. So when you take, there's something going on about 3/4, and I'm not quite sure I can add it up. The double dot, right? Somehow it should be a 7 and not a 3. And the reason is it's 7/8 of something as opposed to 3/4. Okay, so this is, let me check these things out. Okay, so if you have a whole note in 4/4, let's say it's 4 beats. Okay, if you take whole note greater than another whole note, okay, that should yield 1.5 whole notes plus half a whole note. And if you look at, well, that's sort of 1.5 out of 2, which is the same as 3 out of 4. So that's where the 3/4 is coming in. Here's 3, here's 1, it's 4, and the power of 2 made that go. Now, I may be off by a power of 2 or something, but the small one, whether it's the current note or the second note, is it's always 1 to some power. Half a whole is a 1/2, okay? Half of that is a quarter, half of that's an eighth, and so on. All right, so, but 3/4 is not right. I mean, the fact is, like, where's that 4 coming from? I think it's a 2 plus the count, or 2 times, 2 to the 1 plus count. All right. And I think it's almost count minus 1, but denominator's only a 2 because it's 1.5. Okay, if I take denominator times 2 plus denominator times 2, no. Oh dear. All right, so let's take the next step. Whole greater whole goes to, well, it's 1 plus 1.5 plus, I don't know, plus a quarter? 1.75 out of 2 is 3.5 out of 4, which is 7 out of 8. Okay, so I think it's 1.75 whole plus 0.25 whole. Okay, it still adds up to 2 whole notes. But the pattern is, if you took twice this, you have 3 plus 1. And so that's 4. And so we know the small is 1 and the big is 4 minus small equals 3. Here, this is 7/8 plus 1/8. So 1 equals, well, together that's 2. To get it to whole, 3.5 is 4, and then 8. Okay, and so small equals 1, always true. Big equals 8 minus small equals 7. Okay, so I'm getting somewhere. Okay. So if I take, denominator here is 2 for a single one. Okay. And if I take 2, let total equal 2 times denominator. Okay, so that's 4. And let bigger equal total minus 1. Okay, I think I can fold that into one statement without confusing myself. Okay, so if this is 2, this is 4 minus 1 is 3, and so that should be bigger. Okay, this one should still be 1, and this one's always 1. Okay. And now the other way around. This one, always 1. This one is bigger. Denominator. Okay. So that works for 4. I think it's going to work for 2. So let's go back to our original test, which was this, and 7 30-seconds and 1 30-second. Okay, greater than. And I think this should pass now. Okay, and then let's do this one. Well, let's do this. 3. So the first one should be 1/64th. And then this should be 15/64ths. 15/64ths plus 1 is 16/64, which is 1/4. So they start off with 2 eighth notes, and it still adds up to a quarter. I think this is going to be right too. Okay, and we can, this is short. Well, let's do 3 short long. And 2 long short. Okay, I don't know. It's a little weird, but okay. If I can call this double dot. And this is, they call it a Scottish snap. Even though the Strasberry had it going the other way. Dun, 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 dun. This is triple dotted Scottish snap. Let's just say it that way. Maybe just snap. I don't know if they always call it a Scottish snap. All right. And I want to add a single dotted case, just to make sure our generalization, if we ever touch it again, doesn't blow up. Okay, so that was this. This was 3/16, 1/16. Good, good, and good. Okay. Test should still all pass. We added a new one. Okay. Make multiply dotted notes work. Now, let's go back here. That comment can go. Okay, so adjustment. Let's see if we can calculate adjustment. I don't know how good it's going to be about doing this, but let's extract a method. Come on, you can do it. Oh, I guess he can't. He only needs, what does he need? Next event. All right, let's see if we can do it manually. Data note adjustment. It's going to take something. It's going to return a rhythm. Okay, and all of this is working towards return adjustment. But notice it's got this side effect. Ugh. Cannot find next event. Okay, we're going to need next event. Next event. That should make all this go away. I wish I had a way to say side effects. Maybe I can do that. Okay, that works. All right, let's set adjustment and next note adjustment. And this thing's going to return two events, two rhythms. I don't know if I'm really fighting something I shouldn't, but return adjustment and next note adjustment. Okay. And then assign next note adjustment equals adjustment next. And then here, I'm going to say, oh, that should come in too. Okay, and adjustment equals next note adjustment, but now we can't change it. Let's say var new next note adjustment equals rhythm 1 1. Okay, if the next note adjustment was not that, then this becomes that. Next note adjustment. And these definitely set new next note adjustment. And then we'll return new next note adjustment. Okay. Adjustment event and next note. I don't know if I'm working hard to It's the price of passing state around, and I'm trying to make the function not affect the object state. It's only calculating a pure adjustment based on the existing next note adjustment, and well, wait a minute. If new next note adjustment. Okay, let's take this extract method for dotted note adjustment. Okay, now I'm saying if the new next note adjustment is one, if the new next note adjustment coming in was anything other than 1-1, then make it 1-1. Well, I think that makes this redundant, right? If next note adjustment is 1-1, then new next adjustment is 1-1 and doesn't need to be touched. And if next note adjustment is not 1-1, then it sets it to that. So that's definitely redundant. Okay. And then if you have the greater thans, these things, graters or less thans, then we adjust next note adjustment beyond here and then feed it out. Okay, I think that should be good. It's, we're pulling the use of object state and turning it into a pure method. Only calculates from its inputs. So you tell me the adjustment you have. You tell me the next event, and if it's a broken rhythm event, I use it. If it's not, I just pass through. Okay. And if you tell me the new next note adjustment, so the upcoming event and the next note adjustment. I think this maybe comes first. Swap the order of these arguments here and here. Okay, we just by adjustment. All right, should be good. And that method is dotted note adjustment. I'll simplify dotted note adjustment. All right. It's still very much we're still carrying a lot of stuff around, I guess. That's hard. We're dealing with endings, we're dealing with repeats, we're dealing with bar lines and complexity in notes. Rhythm adjustments based on that, but I think we're there. Okay. Let's adjust our to-do rhythm. That took a little work. Okay. Okay, and that was the last of these. I'm not sure what's next. We've got some ideas here. I'd like to make sure these other descriptors get knocked out. I'm not going to worry about this one. Parsons code similarity. This is kind of interesting to me. All right. I think we will deal with these descriptors. They should be handled. We might have to add some, and these path ones, I don't know, that might be worth fighting through a little bit. Inline notes, I don't think those matter. String, also in tune. Yeah, I think we'll just, we'll make sure those descriptors are correct. And that may come into this. I'll move this up. I think this sort by value or column count is worth it, and I think it's not too expensive on the UI we have. We're using the grid, the Swift UI grid that seems to have some way to let you sort. Okay, should we have abstract note independent of octave? That doesn't really come to keys. It's just kind of an outstanding question. Okay. Quantizer. I think this little restriction would be very simple. We'll put it up a little closer to the top. And then I feel like this may be the next big thing we tackle. I really need to get with my user and just kind of confirm, but I'm pretty sure she would like this. My idea is, we can demonstrate real quickly. Okay, so when we do the Parsons code, where's this thing? Twitch. TuneSim. Go back to this one. Okay, so we have these 39 versions, and they're compared to each other, and they're sorted by the Parsons code. So anything down, 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 down R comes early. These two fit that model. This one is down, 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 up, which isn't maybe that bad, And so my idea was something like, I'd like to compare either simply, well, okay, what I want to do is somehow compare these, and the ones that are the most similar should physically be kind of, I want some dots, a dot for each of these, maybe fit the number on. 22 and 34 are very similar as far as they go, okay? And these two are maybe identical or close to it. They should be very close to the same dot. I think it's not quite as close to this. It starts out differently, so maybe that's not right. These two look very close. They're somewhat similar to the first one. Arguably very similar to the first one. They're not quite as defined of a mountain. But, they ought to be in the same neighborhood, where these two, like this one, it's all downs, and so is this one and this one. That one kind of goes nowhere. I think those should be in different clusters, one for the one that kind of fits the normal song pattern, one for these ones that are very down, one for these ones that are kind of hanging around in the middle. Those should be different places. And basically we're mapping some complicated measure of similarity into a 2D measure. Okay. Now the similarity, I could see like this one compared to this one, that looks like this one. It's 1, 2, 3, 4 ups. It's 1, 2, 3, 4 kind of and a half ups. If I were comparing this to any stretch of this one, I would say, well, maybe this one is the most similar. It's got the little notched little volcano, and then followed by 4 ups, and a little volcano followed by 5 ups. I would think if I were sliding this on as if for transparency and trying to pick the best fit, that this sort of center piece would get a good score. Okay, that really kind of matches up. Similarly, the front matches very closely to the front here. Now this one, I don't know. It's pretty good up to there. And then something's going on. It's not as steep or something. Okay. And now I haven't quantized them either. We'll do that real quick. All right. That simplifies some things. Like this thing, nothing at all like this one. Okay. This one is close as far as it goes. This one's pretty close. You know, these two should be clustered very close together. These are similar but weaker, and maybe they should be kind of in the neighborhood, but not as close. But I would love to somehow translate. I want to build a matrix of everybody's similar to everything else. And then the ones that are the most similar get clustered somewhere, is my thought. I used to know a fair bit about clustering, but you know, I may have lost all that. But there are ways. I mean, I remember you can either start from everybody being kind of equally distant and move them closer together, or you can sort of start in clusters, big clusters, and split and split and split. Okay. And I'm sure it will take us some research. Okay. The other thing I mentioned was cutting off, you know, to the quantizer. Maybe we could say, I only want the first 32 measures, and then all this junk would be, you know, okay, something else. But we want some control, you know, and I think if you said maximum measure count 32, that much of this would go away. Okay. So that'll be our goal in the medium term. I think probably next week we'll get to that. I think we'll continue on these kind of cleanup-y things. This is pretty short. This, I think, is pretty short. Hierarchical data I may not worry about, and quantizer is pretty short. So I think given those, we will try clustered Parsons code. And after that, I think I really should put an effort in to make sure we handle everything. So musical elements again, maybe. Make sure we handle or consciously ignore everything. So any legitimate, well, let's say any syntactically correct file gets parsed. Okay. I think that would be a nice stage to get to. And I think if I did the clustering, I don't know, I might want to do some of these input things, but we're getting pretty far for, you know, the usage we've had so far. So I probably we'll get through clustering, maybe do a little bit more, see if I can work with my music person to see if there's any big missing gaps or just kind of pure usability kind of problems, and wrap it up for a while from that. Also, I promised to make it open source. Let's get this part done and then open source. I don't think there's going to be that many people doing this, you know, waiting with bated breath to use it, but we'd like to get it out there for them. All right. So let's make sure everything's good. Okay, and we'll just get that to-do checked in. All right. Well, thanks for joining me today. Next time is tomorrow, Thursday, at 2 to 4:30 Eastern Daylight Time or 6 to 8:30 p.m. UTC. Have a good evening. Take care. Bye-bye.